Alrighty. So ellipses, day 2, 155. So mistake number 50 that I didn't fix before I reprinted them is that should be an, not a, an ellipse, 2 L's, is the locus of points. Remember, what does locus mean? Like a set, okay? Is the locus of points in a plane, so we're two-dimensional, such that the sum of the distances from 2 points, so any point on the ellipse, if I take the distance from that point on the ellipse to 2 different points and I add the distances together, it's the same for any point on the ellipse. What are those points called? Remember this right here? And I know you didn't know the names when we did this, but we took these 2 points right here, right? So the vertices are actually out here, but it's these 2 points right here that you have the same distance all the way around. Focus. Very good. They're focused. So plural for focus is foci. Called the foci, which means focuses, but we don't say it like that. Such that the sum of the distances from the 2 points called the foci is constant, and the foci are always inside the ellipse. So we can have 2 different ways. We don't. It's not an up, down, left, or right type of thing like it was for parabolas, but it is a horizontal or vertical orientation. The standard form equation looks very much like a circle, right? So we saw that x minus h squared plus y minus k squared, but they're in fractions. So you have some fraction plus some fraction equals 1. All right, so the numerators look like the circle stuff, x minus h squared, y minus k squared, and then the denominators are a squared and b squared. If it is a horizontal orientation, a squared goes with what? X or y? A is always the bigger number, so I think is what you're thinking. A is always bigger than b, remember? Well, let's put that up here, that's important. We'll put that like right here. A is always greater than b, which is always greater than 0. And so the reason it's a horizontal is because a goes with x, so this is a squared and this is b squared. For the vertical orientation formula, what's the only thing that changes? The numerators. Good. The numerators just switch places, so this gives me x minus h squared over b squared plus y minus k squared over a squared equals what? So we're going to label some stuff on here because that one picture that I gave you on the other notes and all the stuff we did, there's kind of a lot on the pictures. And so we're going to separate it out a little bit more here. Same stuff, but just looking at it a little bit differently. So from this, which is the center, and let's just go ahead and label it HK. I'm not going to put C because there's a few other C's on here and I don't want that to confuse you. The distance from here to here, what is this point called? This point right here. This is the vertex, right? Which means this is the other vertex. What is this? Co-vertex and a co-vertex, right? All right, so then this length here from the center to a vertex, what is that distance? A. And then the distance from the center to the co-vertex is B. Then these points here are our focus points, right? So that's a focus, and that's a focus. The distance from the center to a focus is what? C. And that's why I don't want to put C for center, because it's hard to tell which is capital, which is lowercase. So this line segment here, what is this thing called? The major axis. And that means the other one is the minor axis. Kind of label a few things over here, but not everything again necessarily. on this one, when we have the vertical orientation, what is this length right here? It's vertical. This is your B, because this is your co-vertex. This distance is your A, and this distance is your C. So wherever the vertices, the foci, and the center lines up, that's going to be your major axis. So now this one here, the vertical one, is your major axis. And this one here is your minor axis. And then this here, what's that little segment called? That is the focal chord, and that helps you get two other points on your ellipse. Everybody okay with all the pieces? Because you got to be able to understand the pieces. That's going to help you write the equations. Yes? What would be the, say that again? Which ones? Oh, that's a good question. Let's go ahead and do that then. The vertices are always on the major axis. So this is a vertex, this is a vertex, co-vertex, co-vertex. So yeah, let's just go ahead and label it all if that helps. We'll make sure. Okay? Good question. So notice vertex, focus, center, focus, vertex. They're all lined up. Same thing here. Vertex, focus, center, focus, vertex. So if I give you a focus and a vertex, and I just tell you that this, here's a vertex point, here's a focus point, you should be able to look at them and plot them and then tell me if it's horizontal or vertical, at the very least, if you can't tell me anything else, because you would know that how they have to line up. Okay? Good question. Anything else? All right, so let's fill this in again from this. So I want you to be looking at the picture because I can't really, well, I can scroll, but it gets annoying, so I'm not going to do that. We know that the center is HK. If we have a horizontal orientation, our vertices are on a horizontal line, right? Which means that your H value changes. And so it's going to be H plus or minus what? What's the distance from the center to the vertex? A. Okay. So if you know what A is, you can just count out from the center in two different directions, and that gives you your vertices. Your co-vertices use B, and they're going to go vertically since it's a horizontal orientation. So it's K plus or minus B. The foci line up with the vertices, which lined up with the center. So again, it's an H that's changing. So it's H plus or minus what? C. Okay. What is the length of the major axis? 2A. Good. Because A is an important letter, or an important value, but 2A is the length of the major axis. 2B is the length of the minor axis. Length of the focal chord, 2B squared over A. And then eccentricity is C over A. Remember, that's how oval it is. Think about your eye. So if it's a vertical orientation, then it's still HK. Remember, the vertices line up with the foci and the center, and it would be vertically this time, so that's going to be a change in your Y. So H stays the same. And remember, the A and B don't always go with X or always go with Y. It's always with the major and always with the minor. So it's K plus or minus A. Okay, A always goes with the vertices. That's how you find the vertices. Co-vertices, you use B. When it's a vertical orientation, B is your horizontal, so it's H plus or minus B. Okay. And I know this is very abstract with just all the variables, but if you can think through this when you have the actual numbers, it helps you get things very, very quickly. Foci line up with the vertices, which line up with the center, so that's all a change in your Y value. So H remains the same, and it's K plus or minus what? C. Does the length of the major axis change? Or is it still 2A? 2A, okay? And this is still 2B. And this is still 2B squared over A. And this is still E equals C over A. Everybody good with all that so far? All right, so what we did on Friday is I gave you the equations in standard form, and we found the information and we graphed it. So today you're not getting them in standard form. We have to put them in standard form, either from general form or from information that we have, and then we also get the information and we graph it. And I don't have as much information labeled out because you don't have to like write all that stuff down all the time. You do have to find it and graph it, but it doesn't have to necessarily be filled out. If you can find it and graph it, then you can give me the points, I know. So what we're going to do, you have some room up here at the top. We're going to actually start this up here so that you have plenty of room vertically. There's enough room there, it just gets kind of long. So, excuse me. Here's our general form. We want to write it in standard form. So we need to get all of our variables on the left and all of our numbers on the right. And we want to group things together. So I'm going to rearrange this a little bit. And I'm going to start with the 4x squared. And then I'm going to take the 24x. Now, what we're going to end up having to do is complete the square. So eventually, but not right this second, I'm going to have to add something in here. Then is going to come the y squared. And then this is a negative 10y. And then I would have to add something in here. And then I'm going to move the 3 over to get this. Okay? Everybody okay with that so far? Now, when we do this, when we complete the square here, we have to be careful because we have a coefficient in front of that x squared. So I can't just take half of 24 and square it. It doesn't work that way, right? So I'm going to factor this out. I've got this. I've got to worry about that before I do it, and I've got to worry about whatever this coefficient is before I take care of that. So I'm going to factor out the 4. So this gives me 4 times x squared plus what? 6x. And then I take half of that and square it, so I get what? Plus 9. Close my parentheses. Plus, well, that's really a 1. You don't necessarily have to write it. I'm going to on this one just so you can follow what we're doing. And then y squared minus 10y plus what? 25 equals 3. And then up here, remember, I needed like a plus, and I was going to have to add those two things there. So I have two things I have to add here, and I've got to figure out what they are. Well, when I go to do that, I'm not just going to add 9. I have to take this 9 and multiply it by the 4. What does that give me? 36. So I add the 36. I take the 25 and I multiply it by what's out here, which is just 1, so you're not really even having to do that, but you won't always have a 1 there, plus 25. Okay. And then I'll bring it down here because we have plenty of room now. So this is going to give me 4 times. This right here becomes x plus 3 squared plus, again, I'm going to go ahead and write the 1 even though you don't have to, times y minus 5 squared equals what? What do I get when I add those up? 64. So I've completed my square. I've got my little x minus h squared and y minus k squared, but I still don't have it in standard form, okay, because I need it to be equal to what? 1. There should be a 1 over here. So in order to make that happen, I'm not going to subtract because that would give me a 0. What do? Divide. So I'm going to divide each thing by 64. Then I go back and I reduce. Got the 4 and this over 64. That's going to give me x plus 3 squared over what? 16 plus y minus 5 squared over what? 64, right? Because that 1 and 64 is just 64 equals 1. And there is your standard form. All you got to know how to do to get to that is complete the square. And it's not super crazy. Okay. Everybody okay with all that? Okay, so now we've found the equation, but now we've got to find everything else, and we've got to graph it. So if I have this, first of all, with this ellipse, is this a vertical or horizontal orientation? Vertical, okay, because y squared has the larger denominator, so it's a vertical, right? Which means A is what? 8. B is 4. And then how do I find C? Good. C squared equals A squared minus B squared. So C squared equals 64 minus 16. What's 64 minus 16? 48. So c squared equals 48. Now, to simplify that square root, what is that? 4 square root of 3. Good. So it's 4 square root of 3, which is my actual answer. And then I need a decimal approximation, which really you don't even need the calculator for that. Let's just think if it was like a non-calculator thing. Square root of 3 is about, what do we say, like 1.7-ish, right? And then I can just double that, and that gives me 3.4, and double that, I get 6.8. And if you take the square root of 48 on your calculator, what do you get? 6.9 something, something, something. So 6.8, when you're graphing on a graph like this, is that a decent enough approximation? It is. But you really do get about 6.9 something. That's where your rounding error comes in. So it's good enough to go and graph something. Okay, so since I have all that, do I know my center? Yes, my center is what? -3, 5. Let's go ahead and plot some of that stuff. We've got -3, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so there's my center point, right? Annis, am I going to have to beat you with my Cody board? Okay, I think Cody learned. All right, so there's my C. Now, since I know it's a vertical orientation, before I find the vertices or the foci or anything else, can I go ahead and plot them? I mean, I can take C. If I know that this is a vertical orientation, from C, A is 8, right? So if I go 1, 2, 3, 4, 5, 6, 7, 8, what point is that? This right here is the length of A. So what is this point? Is it a vertex, a co-vertex, a focus point? What is it? It's a vertex. That's one of my vertices. So from C, I can go 1, 2, 3, 4, 5, 6, 7, 8 the other way. There's another vertex. I know that B is 4. 1, 2, 3, 4. So this is my B length. So what does this point represent? A co-vertex. 2, 3, 4. So if you were asked for these things, I know what A is. I found my A and B, and I found my center point. I've got all that stuff, and I can just pull the points off the graph at this point. So if the whole X plus or minus, or H plus or minus A, or whatever that's confusing to you, I mean, you can do it both ways, but you may not have a piece of graph paper. You still need, if you can understand the concept, it doesn't have to be a beautiful graph for you to figure those things out. All right, so what else can I plot at this point? A focus, okay? So from the center, I know that the focus lines up with the vertices, right? And so from the center, I go up and down about 6.9, so almost 7, so it's about right there. It's a focus. That's a focus right there. So my focus points, the X value is still -3, right? And then it's 5 plus 4 square root of 3. And 5 minus 4 square root of 3. And I don't have to estimate that decimal because I counted the other way. But if you found those first, you might want to estimate that so you could go plot that point, but you can figure out about what it is from what you have. Okay. So the other thing I need is the focal chord. So focal chord is 2b squared over a. All right, so that's 2 times 16 over what? 8? What does that give me? 4. So what does that tell me? What does that give me? Or help me with? Another point, right? So from the focus point, do I go to the right 4? No, because that's the length. I can go to the right 2, and I can go to the left 2. You can find what those actual ordered pairs are too, but that's really not necessary at this point. We're just trying to get our graph on there. So I have all of that stuff, and then I can go in and make it ovally to the best of my ability, but that's where that focal chord length comes in handy. Because otherwise it would be even more pointy than it probably is, or it is when I do it anyway. Everybody good? No? All right. Any questions? All right, let's go to the next one. All right, so here, I've given you some more information. Let's go ahead. I've given you some of the stuff I even asked you for. Let's go ahead and graph this. So our vertices are at 4, 3, 2, 4, 3. There's a vertex. And 4. Oh, did I screw this up? I did. Dang it, this was the other one I was going to fix. It's okay. We'll make it work. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. About right there. I forgot I was going to change 2 of them. I only changed 1 of them this morning. Good enough, right? Make it work. On the homework, I'm pretty sure everything fits pretty nicely. So there's that. And then, so right now, is this a horizontal or vertical orientation? Vertical. If those are my 2 vertices, the vertices go along the major axis. So right now I know it's vertical because there's my major axis, even though I don't have anything else. My focus is at 4, 8, which is that first point that goes off the graph badly. All right, so it asks me for, I got one focus, 4, 8. Can I find a center? You can find it 2 ways. Can you find it by counting? If I don't have a graph mathematically, what would you do to find the center? Okay, get the number and get what number, though? Okay, however many spaces it is. Okay, that's kind of like by counting. So if I don't have a graph to look at, isn't it, you're just finding the midpoint, right? Does that make sense to you? Center is midpoint. Now here, all we're doing right now with the ellipses is vertical and horizontal, so you're going to be able to count or do midpoint pretty easily. But just remember, in what she said, we're going to find it and divide it by 2. That's all midpoint is, it's average. You just take the 2 ordered pairs and you literally add them together and divide by 2. So 4 plus 4 is 8, divided by 2 is 4, which means my x value is 4, which should totally make sense, right? And that's what we would expect to happen. And then 3 plus 9 is 12, divided by 2 is 6. Okay, so if I go to 4, 1, 2, 3, 4, 5, 6, and then I can see that I am 1, 2, 3, and 1, 2, 3 away. There's my center point. So now that I have that, can I figure out what A is? What is A? What's my A value? 3, because your A value goes from the center to a vertex, right? From the center to a vertex. So this right here is A, it is 3. B goes from the center where? To a covertex. I don't have that, I can't count that, right? Can I get C from my graph right now? Because C goes from the center to a focus point, so it is 2. So that means I can also put my other focus point on here. Bam, I got that. They're all lined up pretty nicely. I need B. How do I find that? The little equation here. So C squared equals A squared minus B squared. So this is going to give me 4 equals 9 minus B squared. So B squared equals what? 5. So B is the square root of 5, which is about what? The square root of 5. 2 point what? 2.2 something, close enough to graph. Right? So my other focus point, I'd already graphed it. I can find that. That's 4. 1, 2, 3, 4, 4, right? Focal chord length is 2b squared over a. So that's 2 times 5 over 3. So that's 10 thirds. That's 3 1/3, even if I don't have a calculator there. So 1.5-ish in either direction to get my picture, but I still have to write the equation. Do I have everything I need to write the equation of my ellipse? Yes or no? I would need x minus h. Do I know h? Yes, it's 4 squared over something. Plus y minus what? K, which is 6 squared over. All right, so then these are a squared and b squared. A squared goes under which one? Y. So make sure you don't put 3. It's A squared, which is 9. This would be B squared, which is 5. And that's equal to 1. Oh, sorry. Okay. Well, there's another one that doesn't match. Everybody good with all that? All right. Go back to the front. I want to write something down there that when I'm asking these questions, and either, I don't know, y'all aren't awake or you don't know. Y'all have a little bit of room down at the bottom, right? Because you don't need much. Okay. Okay. A, the A value. That is the distance from center to what? To vertex. Which I'm going to put to vertices. Okay. That's A. B is distance, except I can't write. Distance from center to what? Co-vertices. And then C is distance from center to what? Yes, the focus point to the foci. Okay, so you need to understand that concept there, not just worry about putting it with H and K in the little ordered pairs, but be able to graph it quickly as well and figure out what you need. Okay? Everybody okay with that? Alrighty, so let's go to example 3. Got the center, which is at 1, 2. Let's go ahead and graph that. There's my center point. Focus is at 4, 2. And it contains the point 1, 3. So just from that right there, can you tell me if it's horizontal or vertical? Yes. Which one is it? Horizontal, because this. All right, good. So I got a horizontal. My center point, I have that. Actually, I gave that to you. It is 1, 2. Focus is at 4, 2. So since you know the center and the focus, what can you tell me right now? A, B, or C? C, because this distance right here is C. So that length is 3. All right, so in order to write the equation, I need A and B, way more than I really need C. Now, usually when we have a contains point, that means we have to take the standard form and substitute it in. Let's write down the standard form. This is x minus h squared over a squared plus y minus k squared over b squared equals 1. Well, I have h and k to substitute in. I don't have a or b to substitute in. I have c, which is kind of a combination of them, or it's the difference of the two of them when they're squared, but that isn't enough information for me to find one of them. I would have still have 2 variables. But tell me what I can figure out from the graph. If that point 1, 3 is contained in the ellipse, then what does that point have to be in this particular case? The co-vertex. This has to be the co-vertex. Because if this goes along the horizontal, the vertical right here, from here to the point on the graph, which has to be, there can only be one point there vertically, this is your B. So B is what? 1. So now I could substitute in H and K and do my math and find A, but I don't need to do that, right? Because if I have B and C, can I find A different way? Yes. So C squared is equal to A squared minus B squared. Well, C squared is 9. That's equal to A squared minus B squared, which would be 1. So what does A squared equal? A squared is 10, so A is the square root of 10. Oops. All right, so square root of 10 is about what? 3 point something? It's a little bit more than that. So from the center, I can go 1, 2, 3, and just a little bit, right? That's probably too much of a little bit, actually. So 1, 2, 3, and then from the center, 1, 2, 3, a little bit more. And my focus, my other focus was right here. I know that this has to be my other co-vertex right there. So my other focus point is -2, 2. My focal chord is 2b squared over a. So it'll be 2 times 1 over square root of 10, which is like 2/3-ish, close to that, right? Can you divide that out? So from my focus point, if I go about 2/3, 2/3, 2/3, 2/3. And there's the crap. Okay, so now I still need to write my equation. Oh, my B is in the wrong place. No wonder. See how mine looks weird? Weirder than normal. I put my other co-vertex in the wrong spot. And I didn't notice that till I graphed it, but there we go. I didn't count right. Okay, so there's my terrible looking ellipse. Then I need to put it in this form. I have everything I need. X minus 1 squared plus y minus 2 squared equals 1. So it is horizontal, so the bigger number goes under x, right? So this is going to be 10. There's my equation and my graph. Everybody good? All right. Why don't you get started on the next one while I pass out the homework, and then I will I'll kind of fill it in while you're working. Now, your homework is still copied upside down, but it doesn't matter because you're not gluing it in anywhere. It's just weird when you flip it over, but it wasn't worth wasting all that paper. I'm pretty sure all these graphs work out fine. So I want you to notice something about these, which is kind of what I was trying to get at with this activity that I didn't have the really right supplies for. But the focal points are closer to the center than they are to the vertices, right? And the closer and closer those focal points get, then the more and more your ellipse becomes like a what? A circle. And so what would be good, but I couldn't give you hammer and nails, so I have to figure out some other way that'll make this work and we can do it over and over again, is that if we took this and made the ellipse and we brought the focus points closer and closer and closer, then eventually you would get a circle and you could just kind of see the difference. A circle is just a special case of an ellipse when the foci become the center as they get closer together. Okay? Any questions? We good? All right. Awesome. So your assignments there, like I said, I believe all the graphs work. You know, they fit. If anything goes off, it might go off by 1, but I don't think it does at all. I tried to make them where they would work for you. Okay, make sure you can find A, B, and C and get all that stuff done. And I will give you some graded homework back tomorrow. Okay? All right, you good? All right, got a couple minutes left.